So in our last class, we started our chapter that is dynamic equilibrium and Chatelier principle. So just for the revision part, we are doing this Chatelier principle again. So Chatelier principle states that whenever there is a change in equilibrium, or whenever you can say there is some external force which subject to the change in equilibrium, that equilibrium will shift itself in such a way that it will nullify that particular external change. So it means Lee-Chatelier principle states that when a system in equilibrium is subjected to external change, the system readjusts itself to minimize the effect of that particular change. Clear? For example, if you see in this figure 1, this yellow and blue ball, they are in equilibrium with these green balls. Fine. Now we add two more yellow balls and this equilibrium has been disturbed. So you can clearly see this is disturbed equilibrium. Now this equilibrium has a property that it will readjust itself in such a way that it will nullify that change. Now what happens? The system readjusts itself in such a way that there is now one more green ball and one of this blue and one of this yellow ball, they have been removed. The system is again in equilibrium. So when equilibrium system is subjected to a change, the position of equilibrium moves in such a way as to minimize the particular change. Clear?
Yeah.
Okay. Now in this figure, because of change in external change, this will change towards the right. Now this equilibrium is shifted towards the left. Now equilibrium will shift itself in such a way that it will shift towards itself into the right direction and balance it again. Okay, now we will see it in a chemical, how chemically this happens. Now basically this equilibrium can be changed. The first thing which can be the first point that can change the equilibrium is concentration. Now suppose this is A giving you B, or I will write not A, I will write reactant giving product. So there is a reaction in which reactant gives product and product can again give back reactant. It means reactant are combining together and giving a product and product again dissociate and give back the reactant. Here? Okay. Now,
Yeah.
effect of concentration. Now suppose you have you want to prepare a tea or you want to prepare a something, you want to prepare milk. Suppose you want to prepare a milk, so you have a glass of milk, 200 ml of milk. Okay. Now, if this is a milk, you want a sweet milk, fine. So for making it sweet, what you will do? For making this milk sweet, what you will do? What you are going to do? You are going to add some sugar into it.
Yeah.
Okay. So more amount of sugar you add, more will be the sweetness of this milk.
Yeah.
It means more amount of reactant if you are adding, the more amount of product you are getting. Clear?
Yeah. Yeah.
This is same. More the sugar you are going to add, more will be the sweetness. So in the same way, more the reactant we have, more will be the product. So suppose the reaction is going on. Suppose there's a reaction A plus B is equal to C plus D. Now, if I increase the concentration of A and B, then what will happen? If I increase it from the outside, if I add some more A and B, then what will happen? This reaction will move towards this direction. Yes?
Yeah.
So that the concentration of C and D will increase. And if I increase the concentration of C and D, then what will happen? It will shift towards this direction. Yes? So, yes.
So if you increase A or B, C and D would increase.
Obvious, huh? If you increase C or D, it will go to A and B. So, which means that
So
A
why
and B,
does it say increase in A or B, decrease in C or D?
this is the first option and this is the second option. If you are decreasing the concentration of C and D.
increase in AOB means increase in COD,
increase in concentration of A and B will move the reaction towards the reactant side, sorry, product side. Okay. Or decrease in these two concentration decrement will also lead towards the product side. This is what they are saying. You know, see.
So can you increase C and D as well?
Pardon, what?
So when it says decrease concentration of C and D, can you increase it?
We can decrease it. Okay, wait.
No, because it says decrease C and D.
एक second,
so can you increase it?
We can also increase it. Just give me a second. I will show you with one more example. Just give me a second.
Okay.
The slide is there. You can clearly see the slide.
Yeah.
Suppose sir, you want to prepare ammonia. You know ammonia is NH3. Yes or no? पता है?
Yeah.
Ammonia is formed like N2 plus H2 gives you NH3. This is N2 gas. This is gas and this is a gas. Fine. Some catalyst, all these things are there. I'm not writing it down. Now, if you balance this equation, it will be this one. Here,
yeah.
These two are the reactant and this is your product. Now, first option, if we increase concentration of N2 and H2, then can you tell me what will happen?
The product concentration will increase.
It means reaction will move towards the product. Means reaction will move forward. Yes or no?
Yeah.
Clear about? Okay. Now we also know that this is a reversible reaction. Now what happens in this reversible reaction? This reaction can happen and it can also disassociate and give you these two things. It can also disassociate and give you N2 and thrice H2. Clear?
Yeah.
Okay. Now suppose if I am doing it in a closed vessel. Okay, I am adding N2 from there and H2 from there, N2 and H2 from there, and it is producing NH3 inside it. If only entry can happen, no, so you can say moving of NH3 from these things can happen. This NH3 HN3 is now filled with ammonia. Now after some time, what will happen? This ammonia will break into again H2 and N2. Yes or no?
Yeah.
Clear? So, but my motive is to get a forward reaction. I want to manufacture as much as ammonia I can. So what I need to do? As soon as ammonia is found, I need to take it out so that it will not dissociate again.
Yeah.
Yes or no? Suppose whenever you purchase ice cream, okay. So whenever you are going to eat ice cream, you take it out. As soon as you take it out from the freezer, you start eating it now, or you wait it to melt.
You start eating it.
Why? Why you start eating it? Because you can say what we feel good only when we are eating ice cream that's cold, not by just making it like a shake. Enough. Our main motive is to eat the ice cream when it is solid. Clear?
Yeah.
Okay. Now in this case, our main motive is to production of ammonia. Now as soon as ammonia is produced, I am removing it. Clear?
Yeah.
So that it will not disintegrate and again give you N2 and H2. Now, removing of ammonia means what? Decrease in, if we decrease concentration of NH3, again the reaction will be forward. Is that clear?
So if it's forward, then
if the concentration of ammonia is decreased, this ammonia product is decreased.
Yeah.
So
it will move.
These two are the reactant. Yes.
If it's decreased, then it will move towards the reactant.
Yeah. Okay. If we increase the concentration of reactant, then reaction will move forward. That is toward product. It is toward product. And same case.
Yeah.
Toward product. Now, in this case, this is the product concentration. So we can say so for forward reaction, we can increase concentration of reactant and decrease concentration of product. Clear?
So if reactant concentration is increased, it will move towards product. And if reactant concentration is decreased,
But no, reactant a bit see, I have told reactant concentration increase and product concentration decrease. These two things we have done till now.
No, but what happens if it decreases the reactant?
I will tell. Up to this point, is that clear?
So if it increases, it goes to product, and yeah.
If we increase concentration of reactant, then reaction will move forward towards product. And if we decrease concentration of product, then again reaction will move towards product, forward reaction. Okay? These 2 points are clear?
Yeah.
Now see what you are saying. You are saying what happens if the reactant concentration will decrease. Now suppose again I'm writing this N2 plus thrice H2 gas giving you twice NH3. Now what happens if concentration of N2 and H2 decreases? Clear? This is what you want, huh? That what happens if this decreases? These two mean reactant. If the concentration of N2 and H2 reactant decreases, then reaction will move backward. The reaction will move backward. This side. That is toward reactant. Clear?
Yeah.
Okay, and second point, if concentration of NH3 increases, that is product increases, then reaction will move again backward. That is toward reactant. Clear?
So if it increases the product, like the concentration of product, it moves to the reactant.
It will move towards the reactant. Yes. It means this product is now disassociating into reactant. Clear?
No, because if reactant concentration increases, no, decreases, Yeah, if reactant concentration increases, where does it go?
If reactant concentrations increases,
Yeah, increases. It
we
moves
going,
to the product.
yes,
But if it decreases, it
if it decrease,
goes,
it goes towards
if it
reactant.
decreases, it goes
It
to
goes
reactant.
here.
And then if product concentration increases,
Hmm. It go to
it
reactant.
goes to reactant.
Hmm.
And then if it decreases,
It
it
goes to
stays in
product.
the product. Yeah,
ठीक है?
yeah,
Got it? Clear?
yeah,
Fine. If you increase reactant, it will go this side. If you increase product, it will go this side. Clear?
yeah,
Hmm?
yeah,
Now, if the concentration of reactant is increasing, it means product is decreasing. If the concentration of product is increasing, it means reactant will decrease. Got it?
yeah, yeah,
Pakka?
yeah,
This
I
is
know.
this is the main point of this. Okay?
Yeah,
Chalo ji. Now, when equilibrium, when an equilibrium system adjusts as a result of a change, if there are more product formed, position of the equilibrium are shifted to the right. If there are more product formed, the position is shifted equilibrium towards the right. Right means towards the product. If the more
yeah,
reactants are formed, it means the positions are shifted towards the left. Clear? It
yeah,
depends. Product, if product is forming, then it means it is shifted towards the right, and if reactants are forming, it is shifted towards the left. Now, if you choose equilibria where the reactant and the product have different color, simple experiments can be illustrated. Now, this change in shifting of equilibrium can be differentiated easily with the help whenever the reactant and the product are in different colors. That can be done with the help of this experiment, this chromate experiment. Now see, now this whole thing that concentration changes we are going to study with the help of this chromate example. Now investigating changes of a position of equilibrium with the concentration. Now we have a chromate ion. Chromate ion is CrO4 minus 2 and dichromate ions that is Cr2O7 minus 2. So these two ions are having different colors. Chromate is yellow in color, dichromate is orange in color. Now both of these chromate and dichromate ions is sensitive to the change in acid concentration. So they are sensitive in change in acid concentration. Solution of chromate and dichromate have ions with a different color. This yellow color is due to the chromate ion and this orange color is due to the dichromate ion. And if the concentration of this H positive changes, then this color will also change. Is that point clear?
So if the chromate is
Huh?
orange,
I didn't get
wait,
you. The change is from yellow to orange.
so if yellow goes to orange, then there's
It means if yellow is going to orange, it means a forward reaction. The reaction is
yeah,
shifted towards the right hand side. If orange
yeah,
goes to yellow, it means it is a backward reaction. Here?
yeah, yeah.
Okay. Okay, fine. Now, how this happens? Now look at the figure 3. In this figure, if you see, you would expect that the position of equilibrium could be changed by altering the concentration of reactant or product. Now, this is reactant and this is product.
Yeah,
Okay, so I need to change their concentration. Now, basically, the concentration changes with the help of change in the H positive ion. So as the concentration of H positive ion changes, you can clearly see the shift from yellow to orange here. Okay, now see. Now add a solution of yellow potassium chromate, that is K2Cr2O4 into a beaker. Add a dilute sulfuric acid H2SO4 dropwise until there is no further change. The solution turns orange in color. Now take this solution, you add H2SO4. H2SO4 contains H positive ion. Here, now this
yeah,
solution will change to yellow color. Sorry, orange color. So yellow to orange, just by adding acid. Clear?
Yeah. Yeah.
Okay. Now add aqueous sodium hydroxide. Now, as soon as it changes to this yellow color, now in this yellow color, orange color, now yellow changes to orange. Now in this orange color, add sodium hydroxide. Add sodium hydroxide. Now add aqueous sodium hydroxide, that is NaOH, until there is no further change. The solution will become yellow in color.
So
Clear?
that's from going back to the yellow.
Yes. It means if the concentration of reactant is changing, it is going to forward reaction. If the concentration of product is changing or increasing, it is going towards the backward direction. Clear?
Yeah.
That
Yeah.
is what we have discussed earlier. So it means when you are adding dilute sulfuric acid, you are increasing the concentration of H positive ion. So the increase in the rate of forward reaction so causes the position of equilibrium to shift towards to minimize the H positive ion concentration. The shift decreases the concentration of added reactant H positive. So what happens? The shift decreases the concentration of added reactant H positive. The position of equilibrium shifts towards the right of the equation for making more product. Now, the color change is giving you the idea that it is shifting towards the right of the equation.
Yeah.
Okay. A new position of equilibrium is established toward the product and the solution turns green as Cr2O7-2 forms. As soon as this dichromate forms, that solution will turn orange.
Yeah.
These points are clear or not?
Yeah. Cool.
Clear? Any doubt on this point?
No.
Okay.
Do I have to remember the method? Like,
Yes, you have to remember.
or just
No, you
like
have to,
which one? Like sulfuric acid or
you have to remember this method. They can ask. So how it is doing things. So they can ask that whenever a dilute H2SO4 is added into the chromate solution, the concentration of H positive ion increases, which increases the rate of forward reaction, and hence chromate ion is converted to dichromate ion. Now this shift decreases the concentration of added H. Okay. Now see, the increase the rate of forward reaction. So the cause, this is the position of equilibrium to shift to minimize this change in H positive ion concentration. So now equilibrium, as you add dilute sulfuric acid, it increases the H positive ion concentration. Now the rate of reaction also increases, but this equilibrium needs to shift itself in such a way that it needs to minimize the change of H positive ion. Clear?
yeah.
Now what is going to happen? This shift decreases the concentration of added reactant H positive aqueous. Now, whenever this type of shifting is there, it decreases the concentration of added reactant H positive. The position of equilibrium shifts towards the right of the equation, making more product. Now the position is shifting towards the right and the more amount of product is formed. And a new position of equilibrium is established towards the product. That is, the solution turns orange as Cr2O7-2 is formed. Here,
Yeah.
now opposite thing. Now, if you add aqueous solution of sodium hydroxide, it is you are adding OH negative ion with H positive aqueous ion, decreasing the concentration of H positive ion. Now, if you are adding OH negative ion, so OH negative ion will mix with H positive and form water. That is what you are doing, decreasing the concentration of H positive ion. Now, decreased concentration of the reactant. Now, reactant concentration is decreasing, so H positive aqueous decreases the rate of the forward reaction. Now, as the concentration of reactant decreases, the rate of forward reaction also decreases. Clear? And so cause the position of equilibrium. So the position of equilibrium will shift towards the minimize the change in concentration. I'm again repeating, as the position of equilibrium changes, then it will shift to minimize the change in the concentration. Clear? Now shift
Yeah.
increases the concentration of reactant that has been removed H positive ion. The shift increases the concentration of the reactant that has been removed H positive ion. Here,
Yeah.
the position of equilibrium shifts to the left. The position of equilibrium shifts to the left, making more of H positive ion reactant. Now it will shift towards the left so that more H positive ion is formed and a new position of equilibrium is established. In which case we have this orange color is now again coming to the red one. Oh, sorry, yellow one. Clear?
Yeah.
Any doubt in this case?
No. Fine.
Okay, now see. You have yellow color solution. Now see this. You have yellow color solution. I will explain this a little bit. This is Cr2O4. Now concentration of H positive ion increases. Now as the concentration of this H positive ion increases, it means concentration of reactant is increasing. So the reaction will move forward direction. So it means you will get an orange color of potassium dichromate. Sorry, dichromate solutions. Cr2O7 on Cr2O7. Clear?
Yeah.
As you add H positive ion, it means you are increasing the concentration of H positive ion. It means you are increasing the concentration of reactant. Now, if reactant concentration is increased, it will move towards the product side. So yellow color is changing to orange. Now, if you add alkali, that is base in it, now concentration of H positive aqueous decreases. So it will change from orange to yellow. Clear?
Yeah. Yeah.
Any doubt in this case?
No. Fine.
Okay. So I think that will be sufficient for today. Just go
Yeah.
through this.
Do I have to learn the equation of by heart?
Yes, yes, you have to learn this equation also by heart.
Okay.
They may ask this equation. This is the effect of change of concentration of H positive aqueous on Kr2.
How should I write this in notes? Like all of this?
You have to write, first of all, just write this Lee Chatelier principle, definition, and then effect of concentration, change on
Yeah,
equilibrium.
but like, what do I write from it? Like,
Main point, reactions and main point. Summary of
do
the
I write
summary, not each and everything.
about the
You have to write summary, beta.
of
Main
the
point.
reaction?
Yeah, reactions also. You need to write reaction also. You need to write theory also. Just main pinpoints of just the whole whatever we have studied till now. Clear?
Okay. Yeah.
Any doubt in this case?
No.
Okay.
Fine.
So just give me a second.